Good evening, everyone. Kindly wait for 5 more minutes. Let everybody join. Thank you. Sit meeting join मत किया. नहीं बेटा था. தண்ணியோ இல்லை இல்லை நான் போட சேட் இல்லை நான் போட சேட் வரல அதான் நான் மறுபடியும் இப்போ போஸ்ட் பண்ணுறேன். வாய்ஸ் கேட்குது, எல்லாம் செக் பண்ணியாச்சு. எதனா கேட்கலன்னா உடனே வந்து சொல்லு. பை. ஸ்டார்ட் பண்ணவா? Yeah. Good evening, everyone. This is Saravanan. I'm a PhD scholar at NIT Tiruchirappalli. Hope my voice is audible. Can anyone reply in the chat box? Am I audible?
Yes, you
Yeah.
are audible.
Yeah. Thank you so much. Yeah. Uh, Video is not clear. Is it so?
Yes,
Okay. Or else better I will switch off my video. It may hinder the connectivity. Yeah. Hope my screen is visible. Yeah, we can start. So I am Saravanan, PhD scholar and the Prime Minister Research Fellow at National Institute of Technology. Here I am going to discuss about the previous year's assignments in the NPTEL course Plastic Waste Management. I have planned this session in a manner like first we are going to discuss what Professor Brajesh Kumar Dubey discussed during the weeks, like the 5 courses PPT. I am going to explain once. Then we are going to discuss about the previous year's assignment problems. You can post any doubts in the comment box, and I will answer all the questions at the end of the session. The session will go from 6 to 8 p.m. If you find any difficulty in between, you can unmute and you can talk, or please post in the chat box. And I think the Google Meet may end after 1 hour. I mean, yeah, at 7 p.m. it may have a we may have a closure, and again you please join through the same link, and we will continue the session if it happens. Otherwise, we'll continue up to 8 p.m. Okay, so this is the schedule today. Um, yeah, hope the PPT is visible. Yeah. About me, this is a simple background about me. I have done my BTech in civil engineering from the Government College of Engineering in Tamil Nadu, and my MTech from Anna University. Hope you all know it's in Chennai through GATE score. Then I have joined in NIT Tiruchirappalli in 2021, and I am now the Prime Minister Research Fellow under the Ministry of Education, Government of India. So this is one of simple slideshow about. Yeah, hope the slides are with web page is visible. So this is the Prime Minister Research Fellows website, and these are the list of institute eligible to get the PMRF fellowship, and the only NIT in India to get PMRF fellowship is NIT Trichy, and I am one of the research PMRF in this institute, and I have submitted my proposal, and I have joined as a lateral entry scholar for the PMRF, and as per the deliverable guidelines, I am expected to teach in any of the IITs or Polytechnic or Engineering College or NPTEL courses 1 hour per week to complete my deliverable guidelines. So now the NPTEL has assigned me this course, Plastic Waste Management, as I am having the environmental engineering background. So I am teaching you every week 2 hours as per the schedule every Tuesday, 6 to 8 p.m. And I am receiving a fellowship of 75,000 per month in my third year, and I am getting 80. I will get 8,000 in the next year. So this is a broad introduction about the PMRF. Yeah, we will continue with this lecture PPTs. Hope you have gone through the lecture videos of Brajesh sir, or else I will go through shortly. Yeah, 1 second. Seems like many people are joining still. Yeah, thank you. So, all the credits to Dr. Brajesh Kumar Dubey, sir. This is his PPT that he is explained throughout the week. So, I'll just go through all the slides. We will wind up this in 1 hour, and then we will go to the assignments. So, as you all know, plastic waste is a major problem in all the countries, and it is a major problem to combat the climate change. So we have to look into the plastic is not a problem. Plastic waste management is a major problem because plastic may solve many of our issues, and it is a good invention in the last 2 centuries, and we have a, major adoptions in this invention. But the waste produced out of this plastic are the major issue, and we are trying to manage this plastic waste. And this week we are covering about what is plastic, what are the type of plastic, and the global statistics on how the waste is produced and disposed. That's what we are going to see throughout this week. Okay. Yeah. So plastic, as you all know, is a synthetic or semi-synthetic material, and it is an organic plastic. So that's the major thing. This is the organic link of main chain will contain an organic link, and the side links may be having a molecular group of organic or inorganic blends that may be additives such as plasticizers, fillers, or many other additives such as solvents or pigments. So from our day-to-day life, from brushing to bed, we are using plastic and different blends of plastics, and because it's easy to handle, so we are using plastic in our day-to-day life. And recently, bioplastic production is blooming up, and we are also focusing on how to manage the bioplastic waste that is coming into the organic fraction of municipal solid waste. So projects are going on in managing the bioplastics also. So this is a brief history about the plastic. So Mr. Alexander Fox invented the first semi-synthetic plastic, that is Parkinson. Parkinson was first invented in the year 1862, and it was organic material, consists of cellulose nitrate as a solvent. After heating, it can heated and formed into a product that will retain its shape when it cooled down. So that's the first invention on plastic. Second, it was developed by Dr. Leo, and it was the first synthetic plastic in 1907. So he discovered the thermosetting plastic, that is a phenolic plastic, and he named it that as a backlight. So it is having a property of electrical resistant, chemically stable, heat resistant, rigid, moisture and weather resistant. So this all properties made the product, that is the backlight, to bloom in that century. So how the plastics are made? Whenever a monomer was polymerized or condensed to a polymer, then it is a plastic. Monomers such as ethylene can be converted to polyethylene by the process called polymerization by the addition of additives such as fillers, plasticizers, stabilizers. This and all we are going to see in the upcoming slides. So various additives such as catalyst, fillers, plasticizers are added to the plastic to enhance its properties. So catalyst is the one which accelerates the hardening of resin. Example like Ziegler Naita, that is a catalyst used in the synthesis of alkene chain polymers. Fillers are used, that is an inert material, but also it will impart strength, hardness, and other properties to the plastics. Then some of the other additives such as plasticizer. Plasticizers are the compound that increases the plasticity of the plastic, and it will also impart some softness to the plastic. Stabilizers increase the lifetime of the polymer because any polymer may be a semi-synthetic or synthetic material will undergo some degradation process when it is exposed to sunlight or UV light or oxidation or any other degradation process like heat. It may undergo degradation. To prolong its lifetime and to suppress the degradation, we are using some stabilizers. Tris Tris phosphorate is widely used as a stabilizer in polymerization process. And some colorants like dyes and pigments are also used. This colorants are acts as a both filler as well as it will impart desired color to the plastic. Commonly used pigments are zinc oxide and barylites. Some lubricants are added. During molding process, we'll add lubricant to make the plastic during its fabrication process not to stick with the mold. Other additives such as flame retarders. This is a major additive for the plastic that are used in electronic products. Because some of our electronic products, if you see, this meeting also held in GMeet, and we are listening this meeting through laptop or phone. All the products are made up of plastics only, so it may produce some heat or flames. To retard the heat or flames, we have to use some flame retarders while manufacturing the plastic. So some flame retarders such as brominated or organohalogen compounds are used in the manufacture of plastic as a flame retarders. So these are the additives which make the plastic toxic. The monomers of the plastic, that is the ethylene or some other monomers, are non-toxic. This additives such as flame retardants, pigments, solvents, these are the components that makes the plastic toxic. While degradation or while incineration of this plastic waste, we will expose these materials in the waste form, that is the brominated or halogenated compounds, and it will form dioxin or furans in the plastic fumes. And then solvent are used to dissolve the plasticizers that was already added. Okay. So these are the additives used in the manufacturing of plastics, and some of the process used to manufacture plastics are extrusion, calendering, film blowing, that and all we are going to see in the upcoming slides. So extrusion is a major process used to make plastics of desired shape, or we will use different dies to make the product of desired shapes. So here we can use the screw conveyors or twin screw or single screw conveyors to make the pellets heated into this screw conveyors, and we'll get a molten plastic um in this outlet, and we can add some dye to our desired shape, and we'll get the product. We can make a hollow tube or sheets or any product, we can make use of this screw type of extruders. These are called extruders. But the limitation in the extruder is only we can get a uniform cross section products. The next one is calendering. Calendering is used to produce sheets of plastics like thermoplastics. Plastic duff is pressed between two rollers, and you can get a sheet of plastics. So this process is called calendering. And here the limitation is very thin films cannot be made using this process. So for making thin films, we are using film blowing. Here, the same process like extruder, the molten plastic is coming up and air is also blown through this die. And the plastic film is divided into two hollow sections, and the same was again rolled between two rollers, and we'll get a thin sheet forms. So here upward movement is happening with a bubble of air flowing from the bottom, stretches axially and radially to a diameter of ring, and it will again form a flattened tube between the rollers. Here the limitation is higher cost of production and low efficiency and less accuracy. So this is a process called injection molding. Here the same type of extruder used, but along with the extrusion, we are using pressure, like a hydraulic jack is used to press the mold, and we will get a desired shape in the mold. That's the difference between extruder and the injection molding. Here we are pressing the molten liquid into the desired shape, what we want. Here also it's not economically practical. Then blow molding. Blow molding you can see in our plastic bottles or water bottles. The water bottles are made up of blow molding process. Here after the extrusion, the molten liquid is flowing through a tube, and then compressed air also flown through the same tube, and it will expand to the desired shape and then cool down, and the trimming process is happening. Then we will get the final product like bottle or containers. Then expanded bed blowing. This is the process used to manufacture foamed plastic. This type of foamed plastic can be produced using bed blowing. Here the beads are first filled into the hopper, then it was heated under high pressure. Then we'll get an expanded and blown agent of foamed plastics. It will have a cell structure. The limitation is it will create more waste. Then this is called the rotational molding. In this, the pellets or the raw material for the plastic is rolled to the desired shape under heating. Under heating, it will form the layer around the mold. So this type of drums or syntax tanks can be manufactured by the process called rotational molding. Here you can see first the lower hemisphere is filled with the plastic raw material. Then the top one is fixed along with the bottom one. Then it was rolled under heat. Then the surface is smoothly, inner wall of the mold is smoothly filled with this raw material, and you can get the product after cooling down. So here limitation is it is limited to only hollow structures, and the production rate is also very slow. This is compression molding. Here direct compression along with the heat and pressure, it will complete the polymerization process, and the product was ejected out. And this is a casting process. It's simple like a clay casting. The desired mold is casted with the liquid of raw material plastic is poured without pressure. Just by flowing liquid, it will apply over the shape, desired shape, and it will form the product like spoons or toys we can make using this casting process. Then thermoforming. In this process, the sheet was blown upward or downward using the mold. Here the thermoplastic sheet using a vacuum to pull or to push, and it will form a desired shape. Here also the limitation is high scrap. It will form during the manufacturing process. So these are the characteristics of plastic. Plastic having a high resistance to chemicals and corrosion. Plastic can be both thermal and electrical insulators, and having a high strength to weight ratio. and it was durable, resistance to water, and having a low toxicity. Here in the discussion forum, somebody asked plastic. It was mentioned like plastics are low toxic. Why? Because the monomers used in the manufacturing of plastic is less toxic, but the additives added to make the plastic more durable and more like to suppress the degradation process, we are using lots of additives that makes the plastic toxic during degradation process. So the plastics are seamlessly, limitlessly range of characteristics and colors and are easy to manufacture. So these are the properties make the plastic products to bloom on the last 2 centuries. So we can classify the plastics in different forms. Like by behavior, we can divide into thermoplastic and setting plastics. And by structure, we can divide into homogeneous and heterogeneous plastics. And by physical and chemical properties, soft, rigid, elastomers, and semi-rigid plastics. And type of resin, as you know, we have seven different types of plastics like PET, PPP, LDPE, and HDPE, PVC, PS, and the other plastics. So these are given with the different recycling numbers. The number from 1 to 7 indicates high recyclability to low recyclable properties. So PET is given with the 1. Like that, we have different recycle numbers. So while using any type of plastic, we have to look into the recycle numbers. So PET having a number 1, and it is very easy to recycle. Okay. Going with the first classification based on thermal behavior, thermoplastic and thermosetting plastics. So thermoplastics, if you apply heat, it will soften, and if you cool it, it will again convert into a hardened. We can remold into any shape, and it will again harden to its original shape. But thermoset won't melt under heat, so it can be reused at a great pressure. We can remold the thermoset plastic, but thermoplastic we can easily remold by application of heat alone, and again we can recycle by applying some after cooling down. So this is the properties of thermoplastic. It can be melt before passing into a gaseous state, allows plastic deformation when it is heated, and it is brittle and glossy. Like all of our major plastics are thermoplastics only. They are soluble in certain solvents, and it can swell, and it is resistant to creep. This is the important application of the thermoplastic. Like it can be remolded and reshaped. It has a reshaping capability. And the problem with the thermoplastic is it is more expensive, and melting if heated is the problem with the thermoplastic. So these are the examples of thermoplastic: polyethylene, polypropylene, polystyrene, Teflon, nylons, polycarbonate, acrylics, ABS. Everything is a thermoplastics. These are thermosets. Thermosets are only soluble in alcohol. Um, it is irreversible. It undergo a irreversible chemical process, so it can't be recycled. But it is durable, strong, and hard. Mainly used in engineering application of plastics. Like our laptop was made up of thermosets. Our some of the plastic bottles and the caps are made up of thermosets. So it's more resistant to high temperature. The problem is it can't be recycled and difficult to surface finish. So examples of thermosets are epoxies, polyurethane, unsaturated polyesters, phenolics, and silica. So you can remember this examples. Usually, sir will ask assignments based on this types of examples of thermoplastics and thermosets. Okay, so these are the classification of plastics based on the structure, that is homogeneous or heterogeneous plastics. The monomer contains only the hydrocarbon atoms that are called homogeneous plastics, like polyethylene, polypropylene, polystyrene. Some may have carbon, hydrogen along with oxygen, nitrogen, and other elements that exhibits a heterogeneous structure, like polytetrafluoroethylene, polyvinyl chloride, acrylonitrile butadiene, that is ABS. This and all are examples of heterogeneous plastics. And plastics based on their physical and chemical properties, as I said, rigid, semi-rigid, soft, elastomers. So from left to right, you can see rigid to elastic. The elastic property will increase. So you can see some of the examples here. HDPE, PP, or rigid plastic, PET, or semi-rigid like LDPE, like carry bags are made up of LDPE, flexible ducts, flexible ducts like some crushable tubes you can use in the exhaust pipe. That and all are flexible ducts, PVC sheets, or semi-rigid plastic. Soft plastics are used in children toys, rattles, and fishing baits. Elastomers like polyisoprene, polybutadiene, and polyisobutadiene are elastomers. This we can see in the tires and some of the flexible toys. We can use elastomers, and in the caskets we can use this elastomers. So these are the properties of rigid plastic, having a high modulus of elasticity. As you know, modulus of elasticity is stress by strain. As you all know, having a civil engineering background, modulus of elasticity is stress by strain. So high modulus of elasticity is we need more stress for a simple strain. I mean, for a lower strain to happen, we have to apply larger stress. So that are all rigid plastics. Semi-rigid plastic having a medium modulus of elasticity. Soft plastics having a low modulus of elasticity, it will elongate under pressure, disappear slowly when the pressure is removed. But elastomers are in the room temperature itself, and the application of some pressure, it will expand 10 times of their original dimension. Like this type of tubes, silicon tubes are elastomers. This is the classification of plastic based on the resin or type of plastics. So we have given different codes from code 1 to code 7: PET, HDPE, PVC, LDPE, PP, PS, and other plastics. Other plastic may contain polycarbamide, ABS, acrylic, acrylonitrile, butadiene, LCPs, liquid crystal polymers, and nylon, or other type of plastics. So this code was given in such a way that the first one is easy to recycle, and it will the easiness decreases when the number increases. So this is the basics of this code. Yeah. So this is the explanation for PET. Mostly used plastic in the planet is PET plastic only. As you know, all the water bottles are transparent water bottles are made up of PET only. So this is having a code 1 plastic. So this is the polyethylene monomer used in the manufacturing of PET, and it is oxygen permeable, lightweight, semi-rigid, hygroscopic in nature. So these are the examples for PET, like ketchup bottles. Most of these water bottles and food storage containers are made up of PET. This is HDPE. HDPE was first invented by in 1953 for to make the pipes used in storm sewers and drains and culverts. This is most commonly recyclable plastics are HDPE. Mostly used plastics are PET, and most commonly recyclable plastics are HDPE. So this is the monomer structure for HDPE. It has a high strength to density ratio. That's why it's called a high density polyethylene. So high strength to density ratio it's having, with density ranges from 930 to 970 kg per meter cube. It is harder and can withstand some higher temperature. So application of HDPE for some of the shampoo bottles or detergent bottles, you can see this type of HDPE polymers plastics, and then PVC. So all this type of plastics are even discovered accidentally. Like PVC was also discovered an accident twice in 1938, and it was again it was invented by German chemist. Like a vinyl chloride flakes left exposed to sunlight, so it was converted to polyvinyl chloride. That's a PVC. It's the one of the least recycled material in the world. About only 1% of PVC plastic is recycled every year. So that's why it's called poison plastic. It contains a numerous toxins, because when you burn the polyvinyl chloride, chloride is a halogen, so it's contain a halogenic substance. When you burn a halogen substance, it will release dioxin and furans. So that's why PVC plastics are called poison plastics. So this is um, so application of PVC in so we can't live without plastic, because plastics are also used in medicals, and during COVID times we can see plastics application of plastics in the medical field it's quite extensive. So it is required for the for our day-to-day life. How to manage this plastic waste is the major issue, and we have to look into this in this course. Like tablets are packed in the plastic sheets, and our catheters or plastic tubes are also used in the medical applications. And for floorings, for windows, shades, pipelines, and some manufacturing of some leisures also, we can use PVC pipes. Sorry, PVC plastics. Then LDPE. LDPE is the godfather of the material, and 56% of the all the plastic waste contains LDPE. So this is the monomer of LDPE, and having the name itself indicates low density polyethylene. So its density is very low, from zero point 0.9 to 0.91 to 0.93 gram per centimeter cube, and it can withstand temperature of about 80 degree continuously and 90 degree for a short time. But if you see for HDPE, it have a density of 0.93 to 0.97 kg per meter cube. So application of LDPE in the manufacturing of for packagings like carry bags, or for some plastic bags, we can use this LDPE. And some toys like this type of toys also manufactured using LDPE. And then polypropylene PP. PP was also invented in the year 1951. Only a small fraction of PP is recycled, about 3%. But the plastic having a least fraction of recyclability is PVC, 1%. So this is the properties of PP, that is polypropylene: rigid, opaque, flexible, low density, excellent chemical resistance, a good stability to high temperature and humidity, weathering resistance. So application of PP in food storage containers and chair making, like different knife handles and our storage containers, we can use this PP. Then polystyrene or styrofoam, that is PS. This is also invented in 1939 accidentally, across polystyrene while preparing medication. Like, since polystyrene is lightweight and it is easy to form into a plastic material, it also breaks effortlessly, harmful to the environment. Uh, This is the monomer used in the manufacturing of PS, and it is rigid or foamed. As I already mentioned, the foamed plastic was made up of PS. Like this type of food packaging, like one-time use plastics, are made up of polystyrene, like the food containers, glasses, polystyrene glasses, that and all one-time use plastic cups. Most of the polystyrene are single use. Example: bulletproof glasses, headlamps, baby feeding bottles, everything is made up of this. Yeah. So others are like, in the seventh class, we are merging all this other plastics, like BPA, ABS, everything are coming under this miscellaneous plastics. Polycarbonate, polyacrylic, acrylonitrile butadiene, styrene, fibers, nylon will come under this others or miscellaneous plastic category. Many BPA products fall into this category. So we have to avoid this in the food products, because as I mentioned, seventh others are in the seventh code, so it's very hard to recycle. So it's not very easy to break down, and it is impossible to recycle, but it is having a good property like UV resistant, and it having a glass like visibility. That's why we are using this in the bulletproof. Sorry, I have misplaced this here. Actually, this should come here. Yeah. So other examples of seventh code is polycarbonate, having a UV resistant property. Polycarbonate is used in the aircraft canopies, and Teflon. This is used in the gaskets and vessel lining. Polyamides are used in the clothing fibers. Used in the textile industry, we can use polyamides. And the ABS is acrylonitrile butadiene styrene. Some of you may have seen the Lego toys. That building blocks are made up of this ABS. And then urethanes are used in the cushionings of car seats, and some of the frames and technical laboratory equipments are made up of this urethanes. Yeah. So as of now, we have seen what is plastic, what are the properties of plastic, what are the types of plastics. Now we are going to see about what are the application of major field which utilizes plastics like automobile, industries, medical field, buildings, electrical and electronics, consumer goods, packaging. Packaging constitutes the major amount, major application for plastics, and then optical media. So you can see here the distribution of plastics usage in different industries. Yeah, this is one illustration of about how much plastic was used in the manufacturing of a car, from door panel to tires, from front to rear windshield. Everything is made up of different types of plastics in a car. That is an illustration for an automobile industry. This is for industry machineries. All as you know, all these materials were all this type of steel and iron equipments were replaced with the plastic, since plastic having a high strength to weight ratio and also easy to carry, and water resistant, chemical resistant. So most of the equipment in the industries are replaced with the plastics nowadays. And then for medical applications like IV, respiratory fittings, catheters, surgical equipments, and disposable gloves. As you know, all the masks what we have used, and this protection kit during the COVID, everything was made up of plastics only. And during in the construction industries, from top to bottom, we are using different types of plastics. And a major plastic used in the construction industry is PVC. And then electrical and electronic equipments, as you know, plastic is a good insulator, and it is having a flame retardant capacity as an additive. So we are using this plastics as a major component in the manufacturing of electrical and electronic applications, like different types like ABS, amino resins, epoxy resins, polyester, polyethylene, polyamide carbonates. Everything were used in different types of electrical and electronic products. So this is a simple list, and we have many more type of plastic used in the electrical appliances. And then consumer goods, as you know, personal care products and household products are having most of these are packed with the plastic. And the packaging industry, food packaging and cool drink packaging, everything having a plastic. And optical media like CD, from fiber optics to a floppy, older days floppy, nowadays pen drive, up to pen drive we are using plastic only. Yeah. So these are the application. Now we are going to discuss about the global and Indian statistics. How much the plastic is produced in globally, and how much plastic waste is produced globally, and in Indian scenario we are going to discuss. So this is the distribution of global plastic production. As you see, this is a total of Asian countries like China, Japan, and rest of Asia combinedly producing 50% of the total world's plastic material production. So in China itself, 29%. That is the China is the major producer for plastic, and 4% in Japan, and 17% in rest of India. And NAFTA, that is North American a free trade association, free trade agreement has are producing 18% of total plastic, and 4% from the Latin America, 19% from the European countries, and Middle East is producing 7%. The major production producer for plastic is China. That is production, not the plastic waste. The plastic production is more in China. That is about 29%, as per the Plastic Europe report 2017. Followed by Europe and NAFTA. So these are the percentage distribution for various application. How much plastic is produced? For packaging, we are using more plastic, like about 40% we are using in packaging alone. Followed by building. Building we are using mostly PVC, about 20%, and automotive 10%, and then electrical appliance 6%, household 4, agriculture 3, and others like industries we are using 16.7%. So major plastic was used in the packaging of different types of materials. So this chart explains about different types of plastics and its production compared in 2 years, like 2015 and 2016 data. If you compare, the light blue is 2015 data and green is 2016 data. All the plastic had seen a increase in the production. So totally, if you see, total converted demand is 49.9 million tons of plastics are produced every year in the as per the 16 data. So every year it's going to it's getting increased the plastic production. This chart explains different types of application and different types of plastics. If you see packaging, we are mostly using PE plastics. Like if you see buildings, we are majorly using PVC plastics. Like that, this chart explains you what are the different types of plastic used in different applications. So automobile mostly rely on PP and other plastics. So the size of the circle denotes you how much percentage the type of plastic present in this used for this application. So you can see PVC is high for buildings, PE is high for packaging, P and PP for agriculture, and PP for households. So this is the data of per capita plastic product consumption. That is, it's not related to plastic waste. This is related to plastic consumption. So whole first week is about plastic and plastic production only. So this chart indicates the different countries and their plastic consumption per capita. If you see, India is having lesser plastic consumption per capita because the population in India and China are higher. So if you divide the whole plastic production divided by the population of the country, will get 9.7% for as a plastic product consumption in kg per capita in India. So comparatively, USA is having high per capita plastic product consumption. If you see the data of 2014 and 2017, in India 9.7, it was increased to 11 percent. Sorry, 11 kg per person of plastic consumption. So it's again it's increasing. But if you compare US and US, it's almost equal, and Europe also almost equal. So in India, it's getting increased. So if you divide into India, like different sectors also, we are the plastic consumption is increasing. Like packaging, it's increased. Only in agriculture, the usage of consumption of plastic get reduced from 8 to 2%. So why the plastic product consumption per capita per year increases from 2014 to 2017? As we know, the GDP or the GDP of our country increased in the last decade. So whenever the GDP of a country rises, then the waste generation will also increase. So the consumption increases and the waste production will also simultaneously increasing. This is a breakup of how much plastic demand in India in 2013. If you see, PVC having a major demand of about 28%, followed by PP and then HDPE, then LDPE. Same if you see, in India, Western region consumes more plastic, about 47 to 50%. Northern region consumes 23%, followed by Southern, and Eastern region consumes less amount of plastic. That is east of India consumes less amount of plastic. That is 9%. So this is also a one good representation of how much plastic consumption in India as per 2013 data. Yeah, this is what we have covered for the whole week in the five lectures of Brajesh Kumar Dubey sir. So that I hope this recall will help you to do your assignments. I think all of you know about the NPTEL procedure. Every Wednesday we have to before every Wednesday we have to submit the weekly assignments in the portal. So kindly go through the assignment session in the course. You have to submit the assignment before every Wednesday. Um, so this week assignment you have to do. The last year's assignment I am going to discuss now. The zeroth assignment and the first assignment of 2021 I am going to discuss here. I hope you all are clear with this PPT. If you have any doubt, can you please post in the chat box, or can you unmute and you can ask now? And another one information, the Google Meet is having a limit of 100 people, and it may end within 1 hour. So if it extends, it is fine. Otherwise, if the meet ends by 7 p.m., kindly rejoin using the same link, and we will continue the session again up to 8 p.m. Okay, for the assignment solving session. I hope no questions were posted in the chat. Say few examples of organohalogen compounds. I think one was mentioned in that PPT itself. I think you are talking about flame retarders, right?
Yeah. Yes, yes. In flame retardants, it is mentioned only brominated and other
Yeah,
organohalogen
halogen
compounds.
compounds. Mostly they will use
Mm,
brominated, ma'am, because brominated flame retarders are bromine having a good flame retardant property. So mostly they will use brominated flame retarders. The name itself it's a BFR, brominated flame retarders, ma'am. Other halogens like chlorine or fluorine they will use for flame retardant. Yeah,
okay,
I
thank
will
you.
look into the other examples and I will let you know, ma'am, in the next session.
Okay, thank you. And
Yeah,
in another slide, I think it is slide number 78 or 79.
yeah, ma'am.
Uh, one graph is there. You see, it is slide number 77.
Yeah, ma'am.
Uh, so it is mentioned in the x-axis, it is mentioned PELD, means polyethylene low density.
Yeah, low, I mean
Uh,
LDP in the other way, ma'am.
and PELLD also mentioned. After that, PELLD.
Yeah, that is actually LDPE is the low density polyethylene, and
Yes.
LLDPE is again the lower version of this LDPE having very low density. Again, it's a PE only, ma'am, polyethylene product, but having a very low density.
Okay, thank you. And regarding
We have
resin,
four types of
yes.
PEM. One is high density, medium density, low density, and very low
Mm,
density. These are the four types, ma'am.
okay. Okay, that is means very low density type,
Yeah,
LLD.
LLD is
Is
very
it?
low.
Okay. And regarding resin identification code, you told 1, 2, 3, 4.
Yeah, yeah, ma'am.
Uh,
Yeah.
that importance is only from recycling point of view, from
Yeah, the number
human.
indicates on the basis of recycling feasibility, ma'am.
And regarding use, suppose can we say that if number 3 is mentioned, it is better to use a bottle having number 1, a bottle having number 3. It is better to use
It's
number 3.
not
Can we?
it's not based on better to use, ma'am. Actually, we are
Mm,
using PET a lot, and the major
mm,
technologies available to recycle PET is more actually. So we have a good established technology and feasibility to recycle PET, but compared to PVC in the third number.
Okay, so from use point of view, it has no importance. Only from recycling point of
Uh,
view, that
uh,
number.
yeah, in other way, I can say if you use
Mm,
PET a lot, it is better to recycle.
mm, Yes, that means from recycling point of view, the numbers have importance. So
Yeah,
from
importance. Yeah,
use
yeah,
point of view means which is better to use. Suppose I am having three bottles. One is having number 1, other is 2 and 3, in
yeah,
which I can keep
yeah.
liquid
One,
content and it is better to use.
one,
So
Mm,
it is better to use one.
one. Yeah. Mm,
Mm, Okay, thank
thank you. But property may change. But if you think about the waste management point of view, one is better.
you. Okay, thank you.
Any other doubts, or can I move to assignment session? You can also post the questions in the chat box, or you can also ask in the discussion forum in the NPTEL website. I am also following the discussion forum and I am answering the questions in the discussion forum also. Yeah. Mm. Now we will go to the assignment session. Can you all please post the answers in the chat box? I will show the question and I will read the question. Please answer the answer in the chat box. So this is the first question. What happened to the plastic waste discarded into the environment? It is a biodegradable material, so it eventually disintegrates. It never fully goes away. It just breaks into little pieces. It is no such thing. There is no such thing as plastic waste. All plastics are recycled. It is dumped in the ocean for fish to eat. Can you post the answers in the chat box, everyone, please? You can see the answer in the next slide. Yeah, B is correct. Yeah. So because plastic is not biodegradable, we have a type of plastic like non-biodegradable plastic. Now biodegradable plastic also there. Uh, we have to another one confusion is there. Bioplastic, biodegradable plastic. All the bioplastics are not biodegradable. The name itself, we have a tricky thing. If you think bioplastic, okay, we can use and we can discard, it will degrade. It's not like that. Biodegradable bioplastics are there, non-biodegradable bioplastics are there. So the name bio in the bioplastic indicates the type of resin used in the manufacturing of that plastics. So bioplastic indicates some organic matter, some biologically derived matter are used in this bioplastics manufacturing. If we use naturally available starch kind of thing in the manufacturing of bioplastic, then it is called a biodegradable bioplastic. So the first is not general, it is biodegradable material, so it's wrong. It never fully goes away, it just break into little pieces. That is correct. So plastic will undergo degradation and it will form small plastics, that is called microplastic. That is the major concern nowadays. So if you see from if the fish eats this microplastic, it will eventually end up in the food chain. Again we will consume the small fishes was eaten by bigger whales, and then we are also consuming lots of fish as a food, and it will again end up in the human body and we will degrade into the soil and it will again end up into the food chain. So it is a non-ending process. So plastic having a property of disintegration, not degradation. There is no such thing called plastic waste. That is also wrong. All the plastics are not recycled. So we have a statistics. Only 9% of the plastic waste produced in the world is recycled. Only 9%. Other plastics may end up in landfill or end up in the ocean. Most of the plastics end up in the ocean in developed countries, but countries like India, most of the plastic goes to unscientific landfills or dump sites. So last point is it is dumped in the ocean for fish to eat. That is also wrong. So the answer is B. It never fully goes. It just break into little pieces. Okay. Examples of bioplastics? Uh, uh, you can see the chart in the upcoming video questions, ma'am. Sarah, ma'am, sorry. I'll show the examples of bioplastic in the upcoming slides. Yeah, we'll go to the next question. Where does the majority of the mismanaged waste end up? So this I discussed in the last question also. Yeah, we can say B or C, but the question itself, majority of the mismanaged plastic. So major plastic ends up in ocean. Yeah, C is correct. Yeah, C is correct. So majority of the plastic end up in ocean. That's why nowadays ocean cleanup or Pacific Greater Pacific Patch, that SAR will discuss in the further sessions in the waste management weeks and all. He will discuss about Greater Pacific Patch. That is a bigger island in the Pacific Ocean. It's not an island; it's an island of plastic waste. Due to due to the circular motion of the current waves of ocean current waves, we have all the plastic waste moved to a one place of the Pacific area, and it was ended up as a huge island that's called a Greater Pacific Patch. You can also go through in the internet, and major super funds are allotted to clean up this plastic waste dumped in the oceans. It's not directly dumped in the ocean. It will end up in the sewers, and it will end up in the rivers, and finally it reaches oceans. So this is the transport pathway for the plastic waste. So whatever the plastic we are letting into the rivers or in the sewers, that ultimately ends up in the ocean. Okay. The third question is why the accumulation of plastic waste in ocean is dangerous for marine life. They mistake it for food and cannot digest it. Marine life make mistake it for food and cannot digest it. They can get tangled in it, which hinders their ability to swim. Bacteria of plastic can give coral disease. Yeah, yeah. D is correct. Yes. So the marine life, like fishes, may mistake because plastic in the ocean, not only for marine life, but some of the birds may also attracted by the shining properties of the plastic in the ocean and the microplastic or plastic pieces in the ocean, and it will attract towards the plastic and it will eat this plastic and it will choke into the digestive system of marine life or the birds. So this is a major problem. The second point also discusses the same thing. They can get tangled in it. The you can also see another plastic waste come from major source for plastic waste in the ocean or fishing net used by the fishers. They nowadays instead of threaded nets. Now they are using plastic nylon nets, and they discard the nets in the ocean itself if it get tangled. So the fishes or marine life or get sticked towards to this nylon strings, and it can't escape from out of it, and its life end up there itself. And third point is bacteria on the plastic give coral disease. That's another concern about plastic. So the all the above is correct here. Okay. Fourth question is shampoo sachet, bottles, soap boxes are among those wastes produced by every household. What do you think is the best way to manage this waste? Reduce, recycle, reuse, dispose. Um, uh, yeah, B and C are confusing. A also. So dispose is not an option. Okay. Can we reduce this type of shampoo sachet bottles and soap boxes? I think it blended with our day-to-day life. So I think we can't reduce this uh, usage. But these are all made up of HDPE plastics. As I mentioned, shampoo sachet bottles, soap boxes are made up of HDPE plastic. So HDPE has a higher recyclable capacity. So we can recycle this type of plastics. Okay, the answer is reduce. Okay, I'll look into it. Actually, the answer is recycle also correct and reduce. Some answered A, some answered B. Okay, reduce is a good up. As per the 3R condition, reduce is the first one. We can first go to reduce, then recycle, then sorry, reuse, then recycle. But this is HDPE plastic, so we can go for recycling. So as per SARS and solution booklet, it's reduce. So it's the major suitable option for this type of PET plastics. Okay. So the first question is, which of the following is used to manufacture thin single-use carrier bags? LDPE, HDPE, polycarbonate, PVC. Thin single-use carry bags. Carry bags are made up of, yes, yeah. Carry bags are made up of LDPE. Correct. Okay. The sixth question is, As you know, the carry bags are low density, so low density polyethylene are used in the manufacturing of carry bags. Sixth question is, what does the number in the triangle on plastic container means? That's the number that is the code they are talking about. What is that? It's just a number. Option B is it does not have any significance. Option C, it identifies the number of carbon linked in a polymer. Option D, it indicates the type of resin used. Yeah. The answer is it identifies the type of resin used. Like we can identify like PET. Uh, if number is 3, we can say that is PVC. Like that, we can easily identify. How long does it take for a plastic bag to decompose? Not disintegrate, decompose. Disintegrate, it will happen with all this uh, so to decompose the plastic bags may take, yeah, up to 1,000 years. Plastic bag can take up to 1,000 years. That's correct. Never disintegrate. It's not correct actually. It may decompose after 1,000 years. That's a lifetime. This is the eighth question. Which of the following statements is or true about plastic waste? Plastic waste they are talking about. Toxic residues such as dioxins, hydrogen chloride, and sulfur oxides are released when burnt. This can be used to make compost. Okay. They are resistant to natural degradation, leading to the formation of plastic fragments. According to the Ellen MacArthur Foundation, at least 8 million tons of plastic is dumped into our ocean every year. D. Yeah. Some people mentioned the C. Actually, C have second option. Second is like this can be used to make compost. Plastic cannot be used to make compost. So 8B is wrong. B and C have the option second one. Okay, so the answer D is correct. 1, 3, and 4 are correct. The fourth one I can include here. This is the Ellen MacArthur Foundation's report. As per this report, a staggering 8 million tons leak into ocean every year. That's what mentioned here. At least 8 million tons of plastic is dumped into ocean every year. And as I mentioned, it is resistant to natural degradation. So only it will lead to the formation of plastic fragments, that is disintegration. Then it has a toxic residues like dioxin and hydrogen chloride when burnt. Okay. Moving to the next question. What are the prime causes of increasing volume of plastic waste in the environment? Main causes of increasing plastic volume of plastic waste. Any studies being done on the plastic disintegration in 1,000 years? Yeah, ma'am. I will show you one image. Different plastic and their disintegration. I mean, what is that? They have mentioned. Time to disintegrate. This report I will share with you, ma'am. Uh, Saudi Arabia. Okay. I'll share the report, ma'am. So on a general, they are saying 1,000 years. Different types of plastic have different time to degrade. On a general, it's about 1,000 years only, ma'am. I'll share the studies reports. So for this question, plastic is cheaper, readily available, and has widespread application. Okay, that's the reason for increasing the volume of plastic waste. The chemical bonds that make up plastics are strong, and it will take 400 years or above to decompose. The marine shipping and fishing industries are also responsible for contributing towards plastic waste, particularly in ocean. So all these above reasons are above are the reasons for the increasing volume of plastic waste in the environment. Yeah, all the above. This is question 10. What can you do to help stop plastic pollution? What can you do to help stop plastic pollution? Refuse single-use plastic bottles, straws, to-go containers, and coffee cups and lids. Bring your own reusable bags wherever you go. Ask merchant and restaurant and other establishment you frequent to consider using plastic-free alternatives. So all these options will help you to stop plastic pollution. So D is correct. Yeah, yeah, D. No need to take screenshots and all. I'll share this video. This session recording will be available to you. You can watch this 2 hours recordings of all the weeks anytime. I will share this recording in the YouTube, and I will post the YouTube link in a spreadsheet given to me, and the same spreadsheet will be shared with you through mail also. So no need to worry. You can watch this video and this PPT also. I will share with you. Okay. Yeah. Question 11. The COVID-19 pandemic drastically increased the consumption of single-use plastic in the form of protective equipment and packaging material. Is it true or false? It drastically increased the consumption of single-use plastic. Actually, it's true. Yeah. So, is it mandatory during that time? It was mandatory, yeah, to use the to consume single-use plastic. Yeah. Okay. Okay. Thermoset plastics are recyclable. Is it true or false? Thermoset plastics are recyclable. We had seen two types, thermoplastic and thermosets. Thermosets are recyclable or not? Yeah, it's false. Because thermoplastics are easy to recycle. Thermosets are not easy to recycle. When it was heated, it will directly convert into gaseous phase. But thermoplastic will first convert into liquid phase. That's the molten plastic we will get out of thermoplastic. Then before escaping as a gas. So thermosets are not easily recyclable. Okay, this is the question 13. Reducing plastic consumption and raising awareness about plastic recycling is crucial if we are to overcome the problem of plastic waste and pollution on our planet. Yeah, these are the two things they are asking about. Reducing plastic consumption, raising awareness about plastic recycling. Is it required or not? Yeah. Is it required? True. Correct. Yes. Can I go further? Okay. This is question 14. Circular economy is introduced to close the loop of plastic waste management and convert plastic waste into a sustainable secondary resource. So I think you all know about circular economy. There are two things. One is linear economy and the circular economy. From the production side, we are using, I mean, the consumers are using the product, and then after the end of life of the product, the consumers are disposing the product into the environment. So this is a linear cycle. Um, the resources were extrapolated to produce a product, then the consumers are using the product. At the end of life, the product was disposed into the environment. This is the linear economy. If we use the waste disposed in the environment as a resource for the production of newer material or a product, this is called a circular economy. So we are closing the loop of linear economy to make it as a circular. That is production, usage, end of life, not disposal. End of life, it's again reused in the manufacturing of newer product. This circular economy is introduced to close the loop of the plastic waste management and convert plastic waste as a sustainable secondary resources. Then only the word sustainable is here, because the future generation should not worry for the resources. They can adopt the waste as a secondary resource to make their new products. So this is true. Question 15. Globally, more than 40% of the plastic waste is recycled and 60% is directly discarded into the aquatic and terrestrial ecosystem. Is it true or false? Uh, it's a tricky, yeah. I too answered first true, but it is actually false. Yeah, it's false. I told you, no, 9% only. I can show you the report. Yeah, this is the report. Only 9% of plastic waste is recycled. 15% is collected for recycling and 40% of that are disposed as residues. Another 90%, 19% is incinerated. That is, the waste is collected and it is going to waste to energy plant. It was incinerated to get some energy. 50% ends up in the landfill. 22% awaits waste. I mean, if it is collected, it will end up in landfill. If it is not collected, it will go away into the uncontrolled dump sites. So only 9% was recycled. Rest of 91% is not recycled and directly discarded. I mean, 19% is incinerated, others are discarded in the landfill or ocean. So as per the OECD report. Yeah. Hope you are okay with the answer is false. Okay. This is the 2020 one, sorry, 2022 first assignment, first week's assignment. So can you look into this? Additives and their functions. Why the catalysts are used, why the plasticizers are used, fillers, stabilizers, and solvents. Okay, why the please read and answer. Yes. A, uh, option A, C, then okay, I'll tell the answer. First, the catalyst. Catalyst means any catalyst will accelerate the production process. So here also the catalysts are used to assist and accelerate the hardening of resin. So option is C or D. A is 4, so C or D. Okay. Then plasticizers. Plasticizers improve the plasticity and impart softness to the plastic. So B to 5. This is also okay. Then fillers. Fillers are used to impart strength, hardness, and other properties to the plastic. So C1. Then D, stabilizers. Stabilizers will prolong the lifetime of the polymer by suppressing the degradation. Then solvent. Solvent are used to dissolve the plasticizers used in the plastic production. So the option C is correct. Yeah. So here you can see catalyst, fillers, inert material impart strength. Catalyst assist and accelerate the hardening process. Plasticizers improve the plasticity. Solvent used to dissolve the plasticizer. Yeah. Okay. Then question two. Which of the following method is suitable for manufacturing of sheet material? Yes. We have seen different types of methods used to manufacture the plastics. So sheet material, yeah, C is correct. Yes. Yes. Uh, I request ma'am to switch off your video and audio. Sorry, Sentha sir, can you please? Thank you. Okay, I'll go to the next question. So, sorry, the answer is calendaring. Yes. So you can see calendaring. Here the duff contains thermoplastic was rolled between, sorry, was sent between two rollers and it was manufactured into a plastic sheet. So here the limitation is very thin plastic cannot be possible. Only sheet can be possible with the calendering. Okay. The third question is the category of plastic that can deform considerably under load at room temperature and return to their original shape when the load is released. Um, Deform. So deform it is like soft or elastomers. C or D. Undergo load at room temperature itself. So C or D. Yeah. Elastomers is the answer. D. So here you can see rigid plastic have high modulus of elasticity and retain their shape. Semi-rigid having medium modulus of elasticity will have elongation under pressure. High pressure it will elongate maybe. Soft plastic having a low modulus of elasticity, this is also elongation under pressure and disappears slowly. But elastomers at room temperature itself, it will under small load, it will elongate and return to its original position, and it will extend up to 10 times of their original dimension. Yes. So elastomers is the answer. What is the resin code for polypropylene? PP. You can go through the code. The first one is PET, second one HDPE, third one PVC, then yes, the answer is 5. You can see PET, HDPE, PVC, LDPE, then PPPS. Polypropylene is fifth. Polypropylene is fifth. Yes. Then question 4, 5. Which among the following statement is or correct? HDPE is the most commonly recycled plastic because it will not break under exposure to extreme temperature conditions. PET, I mean HDPE is most commonly recycled, not easy to recycle, commonly recycled. PET is an excellent moisture and water barrier property. PVC is one of the least recycled material. Generally, less than 1% of the PVC plastic is recycled every year. All the above. Yes, all the above is correct. Yeah. So HDPE is most commonly recycled plastic. PET, uh, what they have mentioned, PET is excellent moisture and water barrier material, as mentioned here. This is the property of PET. Then PVC having a least recycled is one of the least recycled material, having 1% of the PVC recycled. Yeah, so all the above. Not recycle PVC recycle every year. The data mentioned, this is the annual data. About 1% of the PVC plastic is recycled every year. If you produce 100 kg of PVC every year, 1 kg of the PVC is recycled, going to the recycling plant. Other 98% end up in the landfill or ocean. That's the data. Not recycled every year. Uh, it's a yearly data. Yeah. Sixth question. State whether the following statement is true or false. The basic structure of plastic generally include a main chain inorganic link and side linked molecular groups and some organic and inorganic blends added as an additive. Uh, no, A is not correct actually. Yes, A is not correct because here is only one tricky option here, that is the inorganic link. I told you main chain is made up of organic link, and the side linked molecular groups are maybe organic or inorganic blends added as the additive. So this is false. So this is the definition of plastic. Plastic generally include a main chain organic link, that is polyethylene or polypropylene, whatever that is polystyrene, having a organic link as a main chain. You can see in that structures also CH, CH, so everything is organic only. Whatever having the hydrocarbon, that is organic. Yeah, here. So the answer is false there. Which one of the following plastic resin is used in cable and wire insulation? Cable and wire insulation. So if you go through the different types of plastic and their application, you can see polyethylene, PE is the resin used in the. So here in the electrical and electronic application, you can see polyethylene is used in the cable and wire insulation. For insulation properties, we are using polyethylene. Polyamide is used in the food processor bearings and adapters. Food processor bearings. Yeah. So the answer is polyethylene here. Okay. So eighth question is, as per the Plastic Europe Market Research Group, we had seen in the global statistics. So the same question, which sector had the highest plastic demand in 2016? So these are all the sectors having different application, which is having the highest plastic demand. Yeah. So the answer is yes. So the answer is packaging. So as we know, 40% of the plastic is used in packaging, followed by buildings 19. Yes. So the ninth question is the plastic manufacturing process in which extruded tube is expanded by internal pressure and is generally limited to a hollow or tubular parts, and some versatile mold shape are called das molding. So generally limited to hollow or tubular parts. That also you have to note down. So extrusion won't give hollow. Injection also won't give hollow. So rotation and blow molding will give hollow structure, but expanded by internal pressure. So it's only blow molding. Rotational molding don't have any pressure. Just it will rotate and the inner surface will have the molten plastic binded to it and it will form a hollow structure like a syntax tank. But blow molding, with the extrusion pressure, it will come up and the air will go in between the two things and sorry, like PET bottles were made. No, the show I had shown some diagrams. So the extruded hot and plastic was extruded into a hollow tube and the air was passed into it. It was blown and then cut into trimmed and it will end up in a container or a bottle. That's called a blow molding. So the answer is blow molding. So you have to look into hollow or tubular parts. So its extrusion won't have any hollow section. Just it will extrude and the die like a cap or something it will made. Same like injection also. Okay. So question 10. According to Plastic Europe 2017, which country is the largest producer of plastic material? Last producer of plastic material, not the waste producer, plastic producer. Yeah. So as we had seen, 50% of the total plastic was manufactured in Asia. In that, major producer is China, about 30%, that is 29%. Yes. Hope you remember this chart as per Plastic Europe 2017 report. So the question 11. The addition of dyes and pigment during the plastic production process helps in two ways. One is acts as a filler and impart desired color. Is both correct or wrong? pigments will impart only color or it will also act as a filler? Think about it. Hmm, can I go to that? Actually, it's true. Yeah. So in the slide also I have mentioned the addition of dyes and pigment help in two ways. One is it will act as a filler and it will also impart desired color to the plastic. So that's the answer. So the answer is true. The colorant will help in two ways. It will also act as a filler, impart strength and desired color. Okay. So the 12th question is which type of plastic is called poison plastic? Yes. Okay. Why? Why PVC is called? Yeah, PVC is correct. Why PVC is called poison plastic? No, sir. Actually, the answer is PVC. Yes, answer is PVC. Why the? It's not because of recycling. What is the full form of PVC? Polyvinyl chloride. So the halogen compound present in the PVC makes it toxic. While burning of halogen compounds, it will release dioxin and furan, which makes the PVC toxic. That's what it was mentioned here. PVC plastic is it has been called the poison plastic because it contains numerous toxin like chlorine. So if it is burnt in the open environment, it will release dioxin and furans. Yeah. 13th question. Which among the following statement is or incorrect regarding the general attributes of plastic? Plastic can be resistant to chemical and corrosion. Plastic are both thermal and electrical conductors. Plastic have a mere strength to weight ratio. Mere means negligible strength to weight ratio. Plastic can be highly durable, resistant to water, and have low toxicity. They are asking about incorrect statement. So first one is resistant to chemical and corrosion. Second, highly durable, resistant to the last one also correct. One second, I will check the meaning of yeah, low strength to weight ratio. So the answer is B and C. Yeah. So both are incorrect statements. Correct. So low strength to weight ratio is wrong. It has a plastic having high strength to weight ratio, and thermally and electrically, it's insulator. It won't conduct thermal and electrical currents. Then that's the property. It is having a very resistance to chemical and corrosion, very high strength to weight ratio, durable, resistance to water, and it has a low toxicity. And they're both thermal and electrical insulator. Okay. Question number 14. Which among the following is not an example of thermosets? I have discussed about, yeah, B is true considering electrical wires. Uh, Wires, no, sir, actually, yeah, I'll explain here. Actually, they are asking about the incorrect statement. The first one is plastic can be resistant to chemical and corrosion. So it's correct statement. Second one, plastic are both thermal and electrical conductors. Plastic is non-conductor. So both thermal and electrical. So it's an incorrect statement. Plastic have a mere strength to weight ratio. They are mentioning about negligible strength to weight ratio. But plastic having a high strength to weight ratio. So that is also wrong. The fourth option is plastic can be highly durable, resistant to water, and have low toxicity. That is correct. So answer B and C are incorrect. Uh, uh, Devran, actually, B is true considering electrical wires, sir. Um, it's actually wrong.
Actually, it will be insulator.
Is yeah, it's
Thermal and
insulator. Thermal and
insulator.
electrical insulator. That's the property of the plastic. Yeah. You are talking about the wires, maybe. Wires are conductors, but the outside coating, what we are seeing in the charger, laptop charger or the phone charger, the outside is PE, polyethylene coating, or is insulator only. Yeah. Okay. This is about what among the following is not an example of thermoset. So you have seen about the examples for thermosets and sorry, I mean thermoplastic and thermoset plastics, which is not an example of thermoset. Teflon, silicon. Teflon is a okay. We'll go. Teflon is correct. Yes. I'll show the answers. So thermoplastic, uh, polyethylene, polypropylene, Teflon, nylon are thermoplastics only. Only thermosets are epoxies, polyurethane, phenolics, silicones, unsaturated polyesters. So kindly remind this. We are having another question based on this chart. Okay. So the fifth question is thermoplastics can be used by remolding as many times as required. Thermoplastics. True or false? Thermoplastics. Uh, yeah. Thermoplastics are thermoplastics are recyclable, can be remolded as many times as required. So true. So this is the difference. So it will soften by heating and hardens when cooled down. It can be remolded as many times as required. But thermosets are not cannot be reused. It requires greater pressure and momentary heat during molding and hardens on cooling. So when it was heated again, it will go into gaseous phase directly and it is very hard. If you see heat applied, the plastic convert into molten state. That is thermoplastic. If you apply heat, it will harden again. That is called thermosets. You can see our chairs. Chairs are made up of thermoset plastic. If you heat, it won't melt. But if you see the plastic covers, LDPE or plastic water bottles, I'm sorry, not this water bottle, like normal transparent water bottle. If you heat it, it will melt. That is called a thermoplastic. Yeah. The 16th question. Which type of plastic had the highest demand in India? Highest demand. Which type of plastic? As per the chemical and petrochemical statistics 2013. This also we have discussed, I guess. Um, yes. In India. Yeah, sir. Abdul sir, can you can unmute, sir, or you can post your queries in the chat box. I think you have raised your yeah, raise it. Okay, maybe by mistake. Okay, the answer is PVC. Yes. So here is the statistics. So if you break up the demand of plastic in India, PVC is in the first place. Like PVC demand is 28%, followed by PP, HDPE, and the LLDPE, then LDPE. So PVC, major usage of PVC is in building sectors, construction sectors. And then if you see I mean, which part of India are using the plastic more, this is also one of the answer for upcoming question. Yeah. So 17th question, flame retardants are added during plastic production to remove fire propagation radicals like H radical and OH radical and others. Is it correct? Is it correct? Yes, actually. Yes, correct. So the flame retardants are added during the polymer plastic production to remove fire propagating radicals like H and OH radicals. That's what mentioned here. Commonly, I mean, they are added during the process to remove fire propagating radicals like H, OH, and others. Yes. So the 18th question is, which of the following is not a property of polypropylene? So kindly go through the properties of different types of plastics and remember some of the properties. If you see the examples of each plastic, then you can easily remember the properties of the plastic also. So it's chemically resistance, weathering resistance, high density, rigid, opaque, and flexible. Hmm. Yes, the answer is high density. Polypropylene, polypropylene. I mentioned polypropylenes are used in foam production. So it's having low density. It's called high. So the high density is not a property. Others like weathering resistance, um, opaque, rigid, flexible are the properties of PP. Yes. Moving on to the 19th question. The type of plastics having a high modulus of elasticity, and retain their shape under exterior stress applied at average or moderately increasing in temperature are called. Yes. So the types of plastic based on elastic properties or physical and chemical properties of the plastics. Like so, we have rigid, semi-rigid, soft, and elastomers. So having high modulus of elasticity is rigid plastics. Yes. So these are the things we have seen. High modulus of elasticity is rigid plastic will retain its shape. Yes. Some questions may be repeated. Kindly bear with me. Sorry. So I have taken all the questions to discuss here from 2 years, 2021 and 2. So it may be repetitive. Which of the following is an additive used to enhance the properties of plastics? We have seen lots of additives. Which are this? Which of the following is an additive? Filler, plasticizers, stabilizers, all the above. Yes. So we have all the above the additives in the plastics like fillers, plasticizers, stabilizers, pigments or coloring, solvents, flame retardants, all are additives of the plastic production. Here we had seen when a monomer is added with additives and undergone a process of polymerization and condensation, it will give a product called polymers, that is a plastic. Additives such as filler, plasticizers, stabilizers, colorants, lubricants, flame retardants, etc. are added. Catalysts are also added under high temperature and pressure. So here, which of the following material is non-degradable? This is actually the zeroth assignment of 2020. So it will be easy. Which of the following material is non-biodegradable? Yes. The answer is C. Yes. Okay. Why do companies use plastic in their product? They are waterproof, they are lightweight, they can be made into any shape. Uh, Not only B, yeah, all the above. Yes. The answer is all the above. Correct. Actually, most of your end assessment, I can say like 40% of your end assessment question will be from the assignments and previous year assignment. So kindly go all or I request everybody to finish the first week assignment today itself. Um, Go through the assignment and only 15 questions every week. So if please answer all the assignments. I have also registered this year's course. So I have finished my assignments. Kindly go through the videos. I'm again explaining all the lecture PPTs here in 1 hour. So I request you to go through the videos once if you have any doubts, or you can post in the discussion forum if you have any doubts. Okay. Um, so please go through the assignments also. It's mandatory. And for certification, it's mandatory to finish at least 6 assignments. So don't miss any assignments. Every Wednesday it will close. Okay. So which of the following is used to manufacture thin carrier bags? LDP, SDP, polycarbonate, poly-PVC. So it's a repeated question. Yeah, LDP is correct. Which of the following common item do not contain plastic? Toothbrush, chocolate wrapper, mobile phone, none of the above. Yes. So all of these items have plastic in it. Yes. Which is the process of reclaiming raw material and reusing them to create new product. The process of reclaiming raw material and reusing them in creating new product is called reducing. So chocolate wrappers is a plastic only. Like if you see, I have a chocolate in my hand, it's having plastic only. Yeah, it's not paper. I don't think nowhere paper is used nowadays. Yeah. Okay. So what is the process of reclaiming raw material and reusing them to create new product? It's the process called recycling. Yes, that's correct. Moving on to the next question. How does recycling help the earth and the environment? Causing less garbage, consume more land space in landfills, makes more garbage, all of the above. So recycling helps in not all the above, causing less garbage. So if you recycle, the waste is diverted from reaching the landfills. So it will not consume more land space. So that option B is wrong. Make more garbage is also wrong. So recycling helps in causing less garbage. Yes. Where does plastic go when we thrown it in the bin? Yes. Where does the plastic go when we thrown it in the bin? Land dump, the ocean, recycling factory, all the above. Yeah, anywhere it can go, all the above. So it's also going to recycling plants. Yeah, some percent, 19% is also going to recycling plants if it is collected and segregated properly. So all the above is correct. Yes. How long does it take for a plastic bag to decompose? That we already seen. That is up to 1,000 years. Yes. Yes. Yeah. Following statement is not true for plastic waste. Which of the following is not true for plastic waste? Produces toxin fume when burnt. Can be used to make compost. It lasts long. All the above. Not true. Which is not true. Yes. So plastic produces toxic fume when burned. That is correct only. So plastic lasts long. That is also correct. So can be used to make compost. That is wrong. Only biodegradable bioplastics are used to make compost. That is also not to make compost. That are compostable. That's it. Yeah. So question 10 is what can you do to help stop plastic pollution? That we had already seen all the above. Yeah, this is a repeated question. The way human use plastic affect the environment. True or false? Yes. Yeah, it's true. Yes. The raw material to make plastic is oil. True or false? Hmm, yeah, it's correct. One of the raw material for making plastic is oil. Yeah, it's true. There are no alternatives to use single-use plastic products. Is it true or false? There are no alternatives to use plastic products. Not only bioplastics, sir. Uh, we have papers. Instead of plastic straw, we have paper straw. Instead of diapers, we are cloths. Instead of plastic carry bags, we can use cloth bags. Instead of plastic cups, now we are using bioplastic cups or reusable cups or stainless cups and paper plates. Sorry, plastic plates and paper plates can be used. Like that, we have many options. I have explained here. These are the options we can choose to. Actually, the option is false. I have one second. I will change this. One second. Yeah, the option is false. Actually, there is no alternative to single-use plastic. Is false. Yes. Here are the options. Alternatives for single-use plastic. Okay. Most of the plastic in the ocean comes from ship at sea. Is it true? Most of the plastic in the ocean come from ships at sea. Yeah, it's false. So plastic in the ocean uh, may come from fishes, but not all the most of the plastic. Most of the plastic in the ocean are from rivers or from the seawars that we have discarded. So this is the main source of ocean plastic pollution is land-based. 18% of the plastic in the ocean originates on the land. That's the report says. That's based on the WWF report. So it's a false statement. Yeah. So 80% of the plastic in the ocean originates from the land. Okay. All plastics are polymers, but not all polymers are plastics. Is it correct? True or false? Yeah, it's true. Yes. So another 15 questions are there. That's the first assignment of 2020. It will be easy. Some of are repetitive only. So 10 more minutes. What is the resin code for polystyrene? So hope you have remembered the code. The first one is PET, second one is HDPE, third one is PVC, fourth one is LDPE, fifth is PP, sixth is PS, and seventh is others. Yeah, sixth is correct. Yeah, this is the chart we can go through. Which of the following statement is correct? Plastic can be both thermally. Okay, this we already seen. Plastic is resistant to water is correct. Yeah, this is the properties of plastics. What of the following is a thermoset? Here, thermoset. They are asking. Polyurethane. Is it Teflon, nylon, or thermoplastics? Yes. Teflon, nylon, or thermoplastic. Polycarbonate also thermoplastic. Polyurethane is thermoset. Yes, that's correct. Which country is the largest producer of plastic material? This we have already seen China. Oh, yeah. This is the report. Okay. Many BPA products belong to which of the following category based on which they are often advised to avoid for food consumption? So you had seen BPA comes under which category? BPA is bisphenol A, bisphenol A. That's the plastic. That's categorized under others. That is seventh code. BPA is under seventh code actually. That's why we are not. It's not. It's toxic. It's not advisable to use in food products or food consumptions like packagings and all. So now you may see some of the water bottles are advised with the BPA free. BPA free plastic like that. Some baby products or toys are advised with the BPA free products that you can see. So it's coming under other. It's toxic, having health hazards. Okay. Which plastic sector had the highest demand in 2016? That you have already answered. Packaging. Yeah. Um, which type of plastic had highest demand in India? That is also already answered. PVC. This is a good question. Plasticizers are a type of additive added while producing plastic to remove fire propagating radicals, prolongs the lifetime of the polymer, improve the plasticity and to impart softness to the plastic, impart strength, hardness and other properties to the plastic. Uh, yes, C is correct. Improve the plasticity and to impart softness to the plastic. Yeah, that's a property of plasticizer. You can see about others. Remove fire propagants are flame retarders. Prolongs the lifetime, stabilizes. Impart strength and hardness, fillers. Okay. Which type of plastic is called a poison plastic? Then you have already answered PVC. Yes. Which of the following is not an additive added to enhance the property of plastic? Which of the following is not an additive? Yes. Fillers, plasticizer, lubricant are all the additives. But Coagulant is not an additive. Yes, correct. Plastic generally include a main chain organic link, side linked molecular group, and some organic and inorganic additives. Is it correct or true or false? Plastic generally include a main chain organic link, side linked molecular group, and some organic and inorganic additives. Yeah, it's true. Soft plastic are those that are soft, elastic, with low modulus of elasticity and that deforms under load up to 10 times and can return to its original shape when released. Is it true or false? Soft plastics. Yeah, it's wrong. Yes, it's wrong. Because soft plastic having low modulus of elasticity, but elastomers are the one which extends 10 times of their original dimension. Okay, so the answer is false. Okay. Commonly used flame retardant in plastic are organohalogen compounds. Is it true or false? Flame retardants. Non-organohalogen compounds. Yeah. False question. Yeah, it's true. So the commonly used flame retardants are brominated flame retardants or organohalogen compounds. Yes. Thermosets undergo irreversible chemical process. Thermosets undergo irreversible chemical process. True or false? Uh, Anisha Uttam, I'm sorry, it's actually true. It will undergo irreversible chemical process. It's correct. Thermoplastics are reversible, but thermosets undergo irreversible chemical process. We can't recycle. That's the properties of thermosets. They undergo irreversible chemical process. Okay, the last question. Plastics are limited to a set of characteristics and color and are hard to manufacture. Plastics are limited to set of characteristics and colors and are hard to manufacture. True or false? Yeah, it's false. Yeah. So thank you so much. Hope you got some idea about the first week materials and previous assignment questions related to the first week lectures. If you have anything to change, you can unmute and you can say, or you can comment in the chat box also. That's all about today's session. Um, those who want to clarify something, you please post it in the chat box and you can ask. Others can leave. Thank you so much for joining. I'll post the recordings of this session in the YouTube, and the same link will be shared with you by the NPTEL team. And I will share the material also. Sure, I will share the lecture material. Lecture material already it's there in the NPTEL. This assignment lecture material I will share surely. I'll share. Thank you so much for joining. The next session will be on next Tuesday, 6 to 8 p.m. Thank you. Thank you all. Yeah, thank you. I'll end the meeting.